Thermaltake Toughpower GF3 ATX V3.0 Power Supply Review. It has an excellent power output, but its noise levels may be too loud for some people. Its main rival is the Corsair, which is not ATX V3.0 compatible and lacks a 12 volts HPWR connection. Thermaltake has recently released its own line of power supplies, ranging from 750 watts to 1500 watts. The lower-end models are manufactured by Channelwell Technology, while the higher ones are made by High Power. In this case, we'll take a look at the stronger one, coming with a 600 watts output, and featuring support for NVIDIA's RTX GPU. No ATX version 3.0 or C5X is needed for this card, so any current motherboard should do the job. But if you're planning to upgrade your system soon, then a PSU like the GF1200 would make sense. It comes with a high-performance 120mm cooling radiator, a 140mm PWM water pump, and other top-notch components, so it should last longer than the 10-year warranty period. The cables are long and the distances between the peripherals connectors are adequate. It would be great to have 3 EPS cables, but the module does not have enough room for additional socket connections. The amount of legacy PCI Express connectors are low, but once you get your power supply, you'll be fine. Lastly, the cable lengths are short and all cables use thin, 14 AWG wires for better electrical performance at higher loads. No in-cable capacitors are used, and all cables use thicker gauge wire for lower voltages at higher currents. Please read our PSU 101 article before reading this one. It contains useful information about PSUs and how they operate. The GF3 1200W uses CWT CSX platform. The power supply unit is designed to provide clean, stable DC voltage to the motherboard. The PSUs feature a modular construction, allowing users to replace individual components if needed. A single plus 12 volts rail provides 12 volts to each PCI Express slot, while two 6+2 pin connectors allow for easy installation of video cards. Two 8A fuse blocks protect against short circuit damage. The power delivery system includes 80+ bronze certified 140mm PWM controlled 120mm fans. The internal circuitry is protected by an EMI filter capacitor. The high-performance capacitors are rated for continuous duty cycle operation. The power supply comes equipped with a removable dust cover and a 3-year warranty. The transient filter includes all the necessary parts, which include a move, NTC thermistors, and a bypass relay. The 2 pairs of bridge rectifiers can handle up to 50 amps of current. These charts show the main rail voltages for a wide variety of different PSUs when they're running from a fixed 40W load up to their maximum output capacity. It's important to note that these graphs don't represent real-world performance, instead, they're just meant to give us a general idea of where each PSU falls within its specifications. Simply put, hold-up times are the lengths of time that systems can continue to operate without having to be shut down or rebooted. Inrush currents are generally caused by short circuits or faulty wiring. They may also occur if the load draws excessive power during startup. When a power supply is initially connected to a system, it begins drawing high levels of power immediately upon turning it on. These initial surges of power draw too much energy from the battery and can potentially destroy the internal circuitry of the power supply itself. To avoid damaging your equipment, make sure your power supply is properly grounded before connecting it to any devices. Leakage currents are usually measured using an electronic device called a leak test meter. To measure them, we use a GW Instruments digital multimeter. We need to check if there is any electrical leak from the power supply. The maximum acceptable limit of an electrical leak is 3.5 mA. It is defined by the EE regulation, which ensures that the electrical leak is low. These tests measure the PSU's performance at different loads and temperatures. They also look at how the fan speeds behave when the power supply runs hot. The PSU has no problem delivering the full load, even at high temperatures, but its noise exceeds 50 dB. For these measurements, we test the PSU's efficiency at a range of different loads from 0% to 100%, which represents the majority of typical usage scenarios.